Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the May-June 2023 paper 1 variant 1 from the 9709 International A-Level Cambridge paper. And this question here is about trigonometry and trig graphs and transformations. So basically it says a curve has equation y equals 2 plus 3 sine a half x. So y is equal to 2 plus 3 times the sine of a half x for x between 0 and 4 pi. Okay, and we have to find the greatest and least values of y. So if we look at this and think about the original curve, which is sine x, before any transformations took place, before anything was done to it. Okay, now the first thing that was done to this in terms of the order of transformations, if we think about it, this is like 2, if we call this, for example, f of x, this is like 2 plus 3 times f half x. This is what this represents if f of x equals sine x, if we say, for example. So what's happened here is you have transformations that take place inside the function where they affect only the x values, and those are the ones that we should always take into account first. So we always first start with the horizontal transformations, things that occur horizontally. Okay, and for those we follow the opposite of BIDMAS, and those are the things that affect only the x coordinates. So this will only affect the x coordinates of all the points. So it won't affect the maximum and minimum values. This will not affect the maximum and minimum values, the greatest and least values of y. It will affect the x coordinates only. So this has no effect on the y values. No effect on y. What has effect on y are these things that are outside the function. So the second thing that we have to consider are the vertical transformations. And in this case, we follow BIDMAS. We actually follow the order of BIDMAS. And in this case here, we've got 3 times f of x and 2 plus 3 times f of x. So we start with the multiplication. So first we start with multiplication, which is a vertical stretch. Okay, and the factor is equal to 3. And the second thing that we deal with is the plus 2, which is basically a translation of 0, 2, because it's going to go up 2 spaces and not move horizontally. Right, so this affects the y coordinates. So these two, these affect this one affects the y coordinates. Okay, so these both affect the y coordinates. Okay, y coordinate affected. All right, so now, so that's what we have to remember in this kind of situation. Okay, now make this a bit thinner. What am I doing? All right, so now, having a look at this then, after we've got understood this won't have any effect. And what we can think about is that the sine of a half x, its greatest value of sine of a half x, the greatest value is equal to 1. And the least value is equal to minus 1. Okay, so if we think about the sine of a half x, just the sine of a half x alone, okay, its least value would be minus 1 and its greatest value would be 1. Okay, so of course, as we can see, it's not affected by any changes, okay, outside the function. So I'll just write it here so we've got space. Sine of a half x. Okay, I have less space for the other stuff now. Then we got to deal with the multiplication. So we're going to do 3 times sine of a half x. So that's going to have to multiply this by 3. We're going to have to also multiply this by 3. Okay, so this is going to become minus 3 is less than or equal to, you've got 3 sine of a half x less than or equal to positive 3. And then we got to deal with the vertical translation, which is add 2. So we got to now add 2 to this, and we got to add 2 to this. And this will be 2 plus 3 sine of a half x. So this can be minus 3 plus 2, which is negative 1. And this is 3 plus 2, which is 5. So our final answer is going to look like this. We're going to say minus 1 is less than or equal to 2 plus 3 sine of a half x less than or equal to 5. So we can say the greatest value is equal to 5, and the least value is equal to negative 1. So there are the answers here. Okay, so the question doesn't actually require us to show all of these steps. You could just write the answers down. It says state, 2 marks stating, 1 for stating each one. You don't have to show all of these steps. As I said, I'm using these videos as a means of teaching students and building up some foundational knowledge of, the understanding of transformations and so on. So that's why I've written all of this stuff down, and I've gone through all that. I could have just written down it in the answer. You could just write minus 5 and minus 1, greatest value 5, least value minus 1, and you would get the marks. But this is the thinking that goes on behind it, which is important for us to really have an idea of. So that's why I have written it down. Okay, now for question 7, part B, we're asked to sketch this curve. So I've got the equation here. We need to sketch this curve. Now, what we have to understand is that we now know the maximum and minimum values for this curve, but we've got to think about some other things. So again, we'll go through our same order. So first of all, let's deal with, okay, we got 2 plus 3 sine, let me write y equals first. So we've got our equation is y equals 2 plus 3 times the sine of a half x. Okay, so that's our curve that we have to deal with. So the first thing we're going to deal with in this, is the things inside the function. Okay, and so that is represented by f half x, which is basically a horizontal stretch, excuse my bad handwriting, stretch of factor the reciprocal of a half, which is 2. So what happens here? The x values are multiplied by 2. The y values, no change. Okay, so that's what happens first. So let's think about what the graph would look like first. If let's say we drew y equals sine of x first. Now the y equals sine x is a curve that starts from here. At pi over 2, it reaches its maximum. Let's say that's 1. And at pi it becomes 0 again. And then it becomes minus 1 at 3 pi over 2, which is halfway between these two. If you forget these values, you can just put them in your calculator and find them. And at 2 pi it becomes 0. So if you want to draw the sine curve, then we've got to basically go through these points here. So try and do it as neat as you can. Okay. And then the sine curve just repeats every 2 pi. So this, I'll just copy and paste it, and it will just repeat again. Just join it onto there, and it should give you, that's y equals sine x. So that's y equals sine x. That's like the original. Okay. Now, when you've done sine if we're dealing with f, this is the first part, which is the f half of x. So we're just dealing with the sine of half of x. We're just dealing with this part first. Okay. So the sine of half of x is going to be all the x values are multiplied by 2, and all the y coordinates don't change. So if we consider each point, this point, the x coordinate is 0 multiplied by 2, so it stays 0, and the y value stays 0. So it starts at the origin. This point is going to be, instead of pi over 2, the y coordinate is going to not change, but the x coordinate is going to be pi. So this is going to end up And I'll just put it in a different color. This point is going to end up over here. Okay, so this point moves to here. Pi 0, okay, the x coordinates are multiplied by 2 becomes 2 pi 0. So it's going to go through here next. 3 pi over 2, 0 becomes 3 pi 0. 2 pi becomes 4 pi. And all these other points are going to be outside of our range because we only want to sketch it for this range here, this interval here. Okay, that's the interval that we want to sketch it for. So all these other points are going to be out. So it's basically going to be going like this. Okay, the 3 pi is going to be basically going like this point as well, by the way. Yeah, that's going to end up over here. Sorry, what did I do? That was incorrect. That point should be down here, by the way. Yeah, because 3 pi over 2 ends up over here. Okay, and then 2 pi ends up over there. So it's going to go up, down, and up again. So it's these two cycles will become like one cycle. Right? It will just be one cycle, basically. So it will look something like this. I'll try and draw as neat as I can. So the maximum still stays at 1. And the minimum still stays at -1. Something like that. I maybe need to go out a bit more. Okay, so let's get rid of this second part. It's not a final answer, so it's all right. In an exam, if you wanted to do something like this, of course you'd be using pencil. Okay. All right, so now, this is now the curve y equals sine of a half x. So now we've got y equals sine of a half x. Y equals sine of a half x. Right, so only the x coordinates were affected, the y coordinates stayed the same. As you can see, the range is still between -1 and 1. Now we're going to deal with the second type of transformation, okay, which is the second thing we deal with. Remember, we have y equals 2 plus 3 times sine of a half x. We dealt with this. So next we're going to focus on, in the order of Bidnas, the multiplication 3 times. Okay, so we got to now stretch everything vertically by a factor of 3. So when it's outside the function, it behaves normal. So it says 3 times, the stretch factor is 3. Right, so here we're going to be, it's like we're dealing with f, 3 times f of x. This is what this represents. 3 times f of x. Okay, which is representing a vertical stretch. Okay, of factor 3. Okay, so here in this case, the x values, no change. No change. But what happens to the y values? Yes, they do change. The y values, okay, they are multiplied by 3. So this point stays where it is because it's 0, 0. If you multiply the y coordinate by 3, it doesn't change. This stays as pi over 2, but instead of pi over 2, 1, it becomes pi over 2 and 3. Okay, I'm just trying to make it a bit more realistic. So that's 3. So this point will move up to there. Pi over 2 and 3. Okay, and this point, pi over 2, sorry, what am I doing? I'm looking at the wrong thing. It's this point. That's bad. Okay, it's this point I'm talking about. Sorry about that. Don't want to confuse you guys. Okay, we finished with the blue one. This is pi 1 becomes pi 3. Sorry about that. Okay, and 2 pi 0 stays as 2 pi 0 because the y coordinate is 0, it stays the same. 3 pi minus 1 becomes 3 pi minus 3, somewhere down here. Okay, this is minus 3, and this stays where it is. Okay, so it's now going to go up, down, and up again like this. I'll try and do it as best as I can. That wasn't very good, was it? Okay, it's a bit difficult with this pen here, but I'll try and, especially when you're getting bigger graphs now. It's going up to there, down to there, up to there. I'm sure that's got in 2 parts now, isn't it? No, actually it's 1 part. All right, so now we've got y equals 3 sine a half x. That's what we've got so far. All right. And the third thing that we want to happen now is we're going to deal with the 2 plus. Y equals 2 plus 3 sine of a half x. Now we're going to deal with this part. Okay, and this represents outside the function something added to the whole function. It represents f of x plus 2, which is a translation of vector 0, 2. So it's like a vertical movement. Okay, so in this case, x values, again, no change. But the y values, we add 2 to them. So basically, the whole of this graph shifts up 2 spaces. Okay, shifts up 2 spaces. Okay, I've kind of like run out of space here, but there should be a 5 here. That should be 2. That should be -1. Okay, and that goes back up to 2 again. Right, so it's something like this. Okay, so that's how the final graph should look. So now what I'm going to do is I'm going to get rid of some of these other things. It doesn't look so I'll get rid of these. Get rid of this one. I'll get rid of these other markings here. I don't need this and this. I don't need this. For a sketch, you only need the values which are really critical. I'll get rid of this as well. Get rid of all of these, and we're left with our sketch that we need. Okay, so something like that. Maybe I should make this a bit, I know I can adjust these things a bit easier than maybe you could. Well, in fact, it's going to turn out to be worse. No, it's not going to help. All right, just leave it like that. I'll just put it a bit lower. I'll just put it a bit lower. And then I can, it's better, put the 5 down here. Okay. All right, so that's how it should pan out in the end. This place should still be the minimum here. All right, so that's not too bad. Okay, and here we finally have y equals 2 plus 3 times the sine of a half of x, and that's the sketch of it. We've got the place where it crosses the y-axis. The maximum value is 5. The minimum value is -1. Goes back up to 2 again where it's that. And that's basically what we need to show. So there is a sketch as best as I could do it. Probably needs to be a bit smoother, but I'm sure that will give you the marks here. And there's the answer to that question. It's only worth 2 marks now. You know, why did it take me so long, and why did I have to write all this down? I'm just trying to explain. I'm trying to explain how the situation works in terms of transformations and giving you a proper background of how to do transformations. As I said many times in the exams, I would not, of course, take this long to do it. Right? It'd be a lot quicker, but I'm trying to use this, as I said, as a teaching tool to help you understand the topic properly. Okay, so that's what this whole purpose is. Now, for the last part of the question, it says, state the number of solutions for the equation 2 plus 3 sine a half x equals 5 minus 2x. For 0, x is between 0 and 4 pi. So basically, this is what's already drawn. And we've got to basically see how many intersections will there be between these two. So when we have y equals 2 plus 3 sine half x, we have y equals 5 minus 2x. When we solve these two equations simultaneously, we're basically finding how many times they intersect. So we got to think about the graph y equals 5 minus 2x. So y equals 5 minus 2x. So if you were to sketch this graph, it will cross the y-axis at 5. When x equals 0, y equals 5. Okay, so it's going to cross the y-axis at 5, which would be here. And it's going to cross the x-axis when y equals 0. When y equals 0, x is going to be 5 over 2, which is, so you have 2x equals 5, x equals 2.5. So where is 2.5? This is pi, which is 3.142. So 2.5 is before here somewhere. So just say this is 2.5. It's just a sketch, so it would have to be accurate. All right, it's definitely, this is pi, this is 3.142, so it's less than pi. So we can see if we were to draw a straight line, okay, because this is a straight line graph, we draw a straight line, it will go basically like this. Okay, and it will continue going down this way, and it will continue going up this way. Right, so it will go up forever here and down forever here. So it will only ever intersect the curve in one place. Okay, so we can say that we just have to state it. Just the answer is one solution. Okay, well, if they say give a reason, because there's one intersection only. One intersection between y equals 2 plus 3 sine of half x and y equals 5 minus 2x. Because they intersect in one place, there'll only be one solution to that equation. All right, so there's the answer to that question. If it was, for example, a shallower gradient and it crosses the x-axis like somewhere at 4 pi, for example. So it went like from this, then there would be 1, 2, and maybe 3 solutions in that interval. Okay, but because we know that it crosses the x-axis before pi, there's no way it's ever going to have any other solutions. This goes up, down. This will continue going up this way and that way. There's no way they'll intersect ever again. So there's the answer to part C. Pretty simple, just one solution. We have to have a good understanding how to draw these graphs and have a understanding of that. But that basically concludes this question. Other questions from this particular paper can be found in the playlist, which will appear on the top right of the screen at the end of this video. Other questions from the topic of trigonometry, trig graphs, you can find in the playlist that will appear in this part of the screen at the end of the video. Other questions dealing with transformations of functions, because it also involves a lot of that, will be here in this part of the screen. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.